Good day everyone, I am Gabriel Lubanube Alamparas of CE14E1. I am from Group 5 together with Carol Lapini, Stephanie Latras, and Nicky Lusterio. What we will be talking today is the experiment we have done, which is the sieving and plastic limit by Atterberg's method. We will be talking about the materials needed, how it is done, and etc. But before that, I will tell you a brief introduction of what our experiment is all about. So the plastic limit is simply the water content at which a soil water phase changes from a semi-solid to a plastic consistency as it is rolled into a 3.175 millimeters or 1/8 inch diameter thread in a standard test. It is done to test the soil to be used for certain construction projects. This test is important to ensure that the soil performs as expected or in accordance to fixed standards. The Atterberg limit, particularly the plastic limit, is correlated with engineering behavior such as compressibility, hydraulic conductivity or permeability, shearing swell, and shear strength. In general, clays with high plasticity have lower permeability, and they are difficult to be compacted. So for the materials needed for that experiment is the first, soil, second, water, third, the number 200 sieve, number 4, sieve shaker, number 5, the triple beam balance, number 6 is the three containers, 7 is the spatula, 8 is the non-absorbent surface, 9 ruler, and lastly oven.
Here is a procedure on our experiment about sieving and plastic limit by Atterberg method. First of all, we need to prepare the soil material for sieving. Using the sieve shaker motor, the soil that passes through number 200 sieve will then be utilized. Weigh the empty moisture cans and record the respective weights and can numbers. Take the soil sample and add water until the soil is at a consistency where it can be rolled without sticking to the hands. The fifth step is form the soil into ellipsoidal mass. Roll the mass between the palm of the fingers and the non-absorbent surface. The thread shall be deformed so that its diameter reaches 3.2 millimeters. When the diameter of the thread reaches the correct diameter, break the thread into several pieces. Knead and reform the pieces into ellipsoidal masses and re-roll them. Gather the portions of the crumbled thread together and place the soil into the containers. Then weigh the can containing the wet soil and record its mass. Repeat steps 5, 6, and 7 at least 2 more times. Place all 3 containers in the oven for at least 16 hours. Then weigh each container containing the oven-dried soil. And lastly, determine the water content from each trial.
Next will be the data and results. The average water content of all trials is the plastic limit, and in this experiment, it is equal to 33.86%. The difference between the